Hello, my name is David Broussard, and this work is about the design and evaluation of visual indicators to help teachers understand students in a VR classroom. So to start, networked VR has long been proposed as an alternative to in-person, face-to-face education. It can potentially increase student engagement and motivation. More recently, in light of the COVID-19 pandemic, it's been proposed as a safer alternative to in-person education. However, teacher awareness is somewhat reduced in VR since you don't get cues like eye gaze and facial expressions you'd ordinarily get just by looking at students. Student motion can also be somewhat less constrained in VR. And in our previous study of networked VR for a remote class with Mozilla Hubs, students reported additional distractions from the VR environment, increased technical problems due to VR, and difficulty getting the teacher's attention. So we sought out to design and evaluate visual cues that would help solve some of these problems by providing the teacher with an overview of student states and compensating for some of the missing cues that are lost in VR. But we also wanted to make sure we're not showing so much information we're cluttering the teacher's view. The main piece of technology used here is a Vive Eye Pro HMD used to estimate student attention and to track the teacher's eye gaze for use in the interface. The fundamental components of our interface are indicators, which are visual elements in the teacher's view that summarize a single student's state. But we want to avoid clutter for large classes, so we use an importance score to hide normal student states. Importance is calculated primarily based on attention level, and attention level is estimated based on eye tracking data. We intersect the student's gaze with objects in the scene, and we use these objects' relevance to influence the student's attention level. Actions are calculated based on other input like head and hand tracking, includes things like hand raising, typing, and speaking. Temperament is loosely related to student emotion and includes things like distress and frustration. Detecting temperament is an active area of research, but currently we only have visualization implemented into this system. So the simplest approach to placing indicators is to place the indicators near the students, like above their heads. But the teacher's field of attention is limited, especially in VR, so we clamp indicators to be inside the boundary of the field of attention. We collapse indicators that get too close, and these indicators become a collapsed indicator that summarizes both student states. Alternatively, we can always collapse to track the teacher's view horizontally within the field of attention at a fixed depth. We call these class-wide indicators. These are some different types of indicator collapse modes we've implemented. In particular, face icons have moving eyes that show the relative eye gaze of the student to the teacher to restore the missing cues that you don't have in VR. To redirect the teacher to potentially off-screen students, we have a number of directional indicators implemented. Different indicator elements may also sometimes appear to be tethered to a student, connecting the student with a 3D cubic curve. These appear by default in urgent cases, like when a student raises their hand, but they can appear all the time in smaller, semi-transparent forms if desired. On the avatars themselves, the eye's pupils reflect eye tracking data, and the eyes themselves change shape to reflect the openness and wideness detected for each eye, as well as the current temperament. Avatars contain a front panel graph that shows the student's recent attention and temperamental history that can be called up by hovering with eye gaze or the controller.
Hello everyone, I am Itoshi and I will be presenting the pilot study of user preferences for different cue types and their parameters. The main objective of the study was to show the interface to the subjects in order to identify reasonable parameters and get their insights about our visual techniques. We did a within-subject study. There were 11 subjects total, 8 males and 3 females, aged 23 to 38. Due to the ongoing pandemic, the subjects were convenient sample of active on-campus university personnel. Each subject began the study with randomized options and cue order. There were 12 questions where they chose between discrete options and 3 questions where they were asked to fine-tune continuous parameters. For example, on the screen, you can see a randomized initial setting where the students are represented by face icons with moving eyes in a class-wide multi-row setting. Edge highlights are used to indicate students' positions, and tethers can be seen to be connecting all students with their avatars. Subjects could then switch between different parameters of each visual cue to voice their choices to the investigator. Each subject was asked to imagine being a teacher while placed in a VR classroom with 20 simulated students. They were positioned in front of an example presentation explaining Java code containing an if-else statement as can be seen in the right side of the screen. While going through different settings of the cue parameters, subjects explained the reason behind their preferences by responding to questions asked by the investigator, who followed a questionnaire. Subjects also gave productive comments about techniques and some representations. They used a controller to interact with the presentation and switch between visual cue settings to choose their optimal option for specific techniques. The following were our main observations from subjects' responses. Participants preferred to see all student indicators in one place and suggested we minimize the amount of information displayed to help focus on urgent students. Students should be represented by indicators displayed in a class-wide group where both indicators and tethers were shown only for important students. Face icons with moving eyes were preferred by 7 subjects as the collapsed indicators. The subject wanted to see positive student states and also suggested to combine similar states such as frustrated and distressed. Also, another suggestion was to reduce the amount of information shown, perhaps by using additional filtering or other organizational techniques. So in summary, we designed and evaluated visual cues that help the teachers understand students in a remote VR classroom. However, a key limitation of our study was that most subjects were graduate students and researchers and not actual professors or people with any other teaching experience. So in future studies, it would be interesting to see how the adjusted interface with optimized visual cues performs with real teachers simultaneously having to teach and manage students with this interface. We also want to incorporate some future work that uses improved sensing techniques for not only attention but also temperament with some physiological sensors. That concludes our presentation. Thank you for your time.